3.6, derivatives of inverse functions. So first of all, let's review what an inverse function is. So one notation to denote that you have an inverse function, if you see f to the -1 of x, that is denoting that this is an inverse function of f of x. I like to just denote it as just stating that g of x is an inverse of f of x. Okay, so if we have f of x right here, okay, a function will only have an inverse if it is 1-to-1. And the only way that a function will be 1-to-1 is if it passes the horizontal line test, which means if you draw a horizontal line anywhere through the function, it should only intersect that function once. If it intersects the function more than once, then it's not 1-to-1 and it doesn't have an inverse. So this one you can see if I drew a horizontal line anywhere through this function in red here, it would only intersect it one time, which means it does have an inverse. To find the inverse, it's going to reflect this line, y equals x. Okay, so this point here is a comma b. This point over here is going to be b comma a. So in blue here is the inverse of f of x, which this notation f to the -1 of x, which is equal to g of x. Okay, which I'm going to say is g of x. I'm going to let that be the inverse. Okay, so that's a quick review of inverse functions. Hopefully you remember that from college algebra. Let's look at the theorem here. The derivative of an inverse function. Let f be a function that is differentiable on an interval I. If f has an inverse function g, then g is differentiable at any x for which f prime of g of x does not equal 0. Moreover, so this is the rule. If g of x has an inverse, okay, and is an inverse, then the rule to find the derivative of the inverse function would be 1 over f prime of g of x, where f prime of g of x cannot be equal to 0. So let's go through the proof of this one. It's a relatively easier proof compared to some of the other proofs that we've done. Given g of x, let f of x be the inverse of g of x. That's what this is saying. Notice the mapping. So if we start with x and we plug it into the function g, you're going to end up at g of x. And then if you plug it into the function f, you're going to go back to x. So, right, so x, right? And then if you plug x into g of x, you're going to have g of x. And then if you plug g of x into the f function, you're going to end back at x as long as f and g are inverses of each other. Okay? So if g of x and f of x are inverse functions of each other, then g of f of x will equal x, or f of g of x will equal x. Again, this is a review from college algebra. This is just how inverse functions work. So next, let's take this f of g of x, which would equal x. Next, let's take the derivative of the equation with respect to x. So if I take the derivative of this right here, this would be a composition of functions, right? So this would be f prime of g of x, and then you have to take the derivative of g of x, which would be g prime of x. That should be familiar of the chain rule, which is equal to 1 because the derivative of x is 1. Now if I solve for g of x by dividing both sides by f prime of g of x, I've proved the rule. So hopefully you can see here that g prime of x will be equal to 1 over f prime of g of x. This is the rule to find the derivative of the inverse of a function. Let's take a look at an example. Find the derivative of the inverse function. Let f of x equal 5 minus 2x cubed and g of x be its inverse. What is the value of g of x when x is equal to 7? So, x, g of x. What is the value of g of x when x is 7? Also notice that okay, these are inverse tables of each other. So for g of x, okay, if x is 7, for f of x, this would be 7, because the domain of this function is the range of this function. Okay, so what is the value of g of x when x equals 7? So we don't have the g of x function, but we have the f of x function. And we know that, okay, we can figure out x when f of x is equal to 7. So we could subtract 5. We could divide both sides by -2. Okay, so x would have to be equal to -1 here, right? Because -1 times -1 times -1 would be -1. So now we know that this is -1, which means this has to be -1. So now we have found what is the value of g of x when x is 7? G of 7 is equal to -1. This is review. This is all college algebra. Hopefully that makes sense. Now, what is the value of g prime of x when x is equal to 7? This is we know that this is an inverse function, right? So g prime of x is equal to 1 over f prime of g of x, right? Okay. And basically they want us to find g prime of 7. Oops, put 7 there. So we know g prime of 7 is -1. So I can replace g of 7 with -1. And now I need to find f prime of x. Well, f of x is right here. So f prime of x would be -6x to the positive second power. So f prime of -1 would be -6 times -1 squared. So that's going to be -6. So this is going to be 1 over -6. That would be our answer.